This is section 3.5, Parallel Lines and Triangles. Our objectives today are to use parallel lines to prove a theorem about triangles and define the measures of angles of triangles. Now first we're going to take a look at the parallel postulate. So the parallel postulate says, through a point not on a line, so we have a point right here that's not on a line, there is one and only one line parallel to the given line. So there is exactly one line that can go through point P and be parallel to line L. So if I drew this another way, there's only one way that I can have this. Other ways through the point, it's not going to be parallel. So that is the only possible way. Okay, so next we're going to look at the triangle sum theorem. So all this says, the sum of the measures of the angles of a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C is always going to equal 180. Even if you have a crazy looking triangle like this. If those lines were straight and I found the measure of each of those angles, they would equal 180. Okay, so let me do this. So this triangle, the inside, the sum of the angles is 180. This triangle, the sum of the angles is 180. So it doesn't matter how close it is, all of these are equal to 180 no matter what the shape of the triangle. Now let's talk about an auxiliary line. An auxiliary line, it's a line that you add to a diagram. To help explain relationships in a proof. So an auxiliary line is a line that you personally add to a diagram to help explain relationships in a proof. So now let's take a look at this lovely proof we're going to do. Okay, so let's take a look at this. So we want to prove the angle sum theorem. Now the angle sum theorem is that the sum of the interior angles of a triangle are equal to 180 degrees. Our given is that we have triangle ABC, and we want to prove that the measure of angle A plus the measure of angle 2 plus the measure of angle C is 180 degrees. So the first thing we've got to do is take care of PR. Line PR is an auxiliary line. So we are going to begin our statement with that. So we're going to start off with draw line PR through point B. So that it is parallel to segment AC. And our reason over here is going to be the parallel postulate. Okay, so our reason was the parallel postulate, and I just used the symbol for parallel. Now step 2 is, let's see, what are we going to say? So we can say that angle PBC plus angle 3, those two angles are supplementary. What do they form? They form a linear pair. So we've got angle PBC, and it's okay that this big angle contains 2, as long as we can name it with 1, plus angle 3 are supplementary. So angles that form a linear pair are supplementary. Okay, so when I'm looking at this, I see that I need to get to where I'm talking about the measure of the angle. And right here I am not talking about the measure of the angle, so let's take it a step further. So if I say the measure of angle PBC plus the measure of angle 3 equals 180 degrees, that is the definition of supplementary angles. Okay, so let's take a look at where we're headed. So we know that line PR is parallel to segment AC, so I'm going to put my little notation for parallel. And I know that these angles are 180. Oh wait, these are parallel? And I know that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. I know that the interior of my triangle, that those angles sum up to be 180 degrees. I've got parallel lines. Oh, and I've got a transversal. So angle 1 and angle A are congruent. Angle 3 and angle C are congruent. So if I can figure out a way to write that in my proof, then I am golden. Okay, so I need to get this in terms of angles 1, 2, and 3 instead of angle PBC plus angle 3. So I'm going to say that, the measure of angle PBC is equal to the measure of angle 1 plus the measure of angle 2. So PBC is right here, and it's made up of angle 1 and 2. And what's my reason for that? The angle addition postulate. Okay, so I think I can go now. I'm going to substitute in the measure of angle 1 plus the measure of angle 2. So measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So I looked at this spot right here, and I substituted in the measure of angle 1 plus angle 2, where measure of angle PBC is. So I think I just gave you a big hint on what the reason is. Substitution. Okay, so now let's see, what can we do? I need to do some work with A and C. Okay, so I am going to say that angle 1 is congruent to angle A, and angle 3 is congruent to angle C. So that's what we talked about earlier. Now, why can we say that these two angles are congruent? Well, if the lines are parallel, then what? Then the alternate interior angles are congruent. Okay, so now we're ready to, we need to get it in the measure form, or in the terminology. So we're going to say the measure of angle 1 is equal to the measure of angle A, and the measure of angle 3 is equal to the measure of angle C. And what's the reasoning behind that? Definition of congruence. Or if you wanted to write it out in words, congruent angles have equal measure. Congruent angles have equal measures. And last but not least, step 8. So we now know that the measure of angle A plus the measure of angle 2 plus the measure of angle C is equal to 180 degrees. What property do we use here? So we looked back at step 5, where we had said the measure of angle 1. Oh, and what do we know? The measure of angle 1 is equal to the measure of angle A. So we substituted that in here. So then we had the measure of angle 2, measure of angle 2, measure of angle 3. Oops. Oh, well, we know that the measure of angle 3 is equal to the measure of angle C. So we substituted that in. So our final reason is the substitution property. Okay, so on this problem, they're asking us to find the values of x and y, and we're going to go ahead and find z also. So we've got one triangle, one large triangle, and two smaller triangles. So let's look at triangle ABD. So I can say 43 plus 59 plus x equals how much? 180. So that adds up to give me 102 plus x equals 180. Subtract 102 from both sides. So x is equal to 78. Now, for this one, I know that that forms a linear pair. So I'm going to say x plus y equals 180. So x is equal to 78 plus y equals 180. minus 78 from both sides. So y is equal to 102. And now let's go ahead and find z just because. So z is equal to 49 plus 102 plus z equals 180. Combine those together and I get 151 plus z equals 180. Subtract 151 from both sides. So z equals 29. And always put your degree symbol when we're talking about this. Okay, so the next thing we have is a little bit of terminology. So the exterior angle of a polygon is an angle that's formed by a side when you extend it, like on this one. Angle 1 is an exterior angle. The two non-adjacent, 2 and 3 in this case, when you add those up, those are going to equal 1, the value of angle 1. So angle 1 is equal to angle 2 plus angle 3. Angle 1 is equal to angle 2 plus angle 3. So this can come in really handy. And that was essentially the triangle exterior angle theorem. The measure of each exterior angle of the triangle equals the sum of the measures of its two remote interior angles. So if angle 1's right here, the two angles that are furthest away. So let's put that to use and see what we can figure out. So what is the measure of angle 1? Well, my two angles, 80 plus 18, so I know that angle 1 is equal to 18 plus 80, which is equal to 98. Ooh, now what's the measure of angle 2? So in this case, they gave us the exterior angle, and they want us to find the interior angle. So to do this, we're simply going to subtract 59 from 124, and so we know that angle 2 is equal to 65 degrees. Now how can I check that? I can say, okay, is 65 plus 59 equal to 124? And when I plug that into my calculator or I do the math on the side, I see that it is. Okay, last problem. So we've got a multiple choice question. It says when a radar tracks an object, the reflection of signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. At the right, there's a radar receiver at A, an airplane at B, and the plane's ghost at D. What is the value of X? Well, I look and I see that my exterior angle is 80. This is at 30 degrees. I know that the sum of these two angles has to give me 80. So 30 plus what gives me 80? 30 plus 50. And that's it.